Hello, friends. I hope you and all your near and dear ones are safe and healthy. These are difficult and unprecedented times, and among all the talks, discussions, and panic around COVID 19, I think the best I can do for you right now is to create a peaceful state of mind through distraction via education. So, over the next 8 to 10 minutes, let's zero in on another lead code problem called LRU Cache. This is a frequently asked question by Amazon, Google, Facebook, Microsoft, and quite a few other companies. I'm sure most of you who are watching this video would be familiar with how LRU Cache works, but let's quickly spend a couple of moments to understand about it. So to start with, a cache is a small amount of memory. It can either be hardware or a software component that stores data so that future requests for that data can be processed faster. Now, due to the limited size of the cache, when this memory is fully utilized, we need efficient eviction techniques so as to accommodate new data. One such cache eviction technique is LRU, which stands for least recently used. As the name suggests, in this policy, the least recently used items are evicted from the cache when the cache is full. Let's go through the problem description. Design and implement a data structure for least recently used cache. It should support the following operations: get input, get key will return the value of the key if the key exists in the cache, otherwise it will return a -1. Put key value will set or insert the value if the key is already not present. When the cache has reached its maximum capacity, it should invalidate the least recently used item before inserting a new item. Now let's go through this example. So we have a cache with the given capacity of 2, and then we have a set of instructions. Let's try to understand it more pictorially. Our first instruction is cache.put 1, 1. So since the cache is empty, we can just insert this element. Next we do a cache.put 2, 2. Since there is still room for one item in the cache, we can simply insert it and update the position. So now 2, 2 is the most recently used and 1, 1 is the least recently used. Next we try to fetch 1 from the cache. So we do a cache.get1. Now we return the value 1 and also update the position of 1, 1 in the cache. Since now 1, 1 is most recently used, so 2, 2 now becomes the least recently used item. Next we get 3, 3. Now we'll have to evict 2 since the cache is already at its capacity and 2, 2 is the least recently used item. We'll evict 2, 2 and also update the position of 3, 3. Next we do a cache.get2. Since the item is not present in the cache, we simply return a -1. Then we have to insert the element 4. Again, we find that the cache is at its full capacity. So we'll have to remove an item which is least recently used. In this case, it is 1, 1. So we remove it and also update the position so that 4, 4 is the most recently used and 3, 3 is the least recently used. Next we do a cache.get1 and return -1 since the item is not found. Next we do a cache.get3. Again, if you see, we have updated the position of 3, 3 now, since 3, 3 is the most recently used and 4, 4 becomes the least recently used here. Next we do a cache.get4. So again we'll have to update the position of 4, 4 and make it the most recently used, and similarly make 3, 3 the least recently used and return the item 4, 4. So let's think about a data structure first before moving on to the code. So since we have seen that we have key value pairs in the cache, we'll need some sort of a hash map which can retrieve the values pretty quickly given a key. But the only problem with the hash map is it is unordered. But here we need to form some sort of ordering so that we can always get the least recently used item from the cache in constant time. So for that, we can use a linked hash map which will solve both the purpose of a hash map and a list which will give us ordered elements. So let's try to write the code now. So we'll have to define two variables, one that holds the capacity of the cache. So we write in capacity Next, we'll define a linked hash map, and it will hold integer comma integer since both the key and values are integers. Now let's initialize the constructor. So this dot capacity is equal to capacity, and we'll initialize the map to a new linked hash map here, and we'll provide capacity which will determine the size of the hash map. Now let's try to implement the getKey function. So as we have seen, if the key already exists in the hash map, so we write if map.contains key, then what all we have to do is first get the object from the cache, update its order in the cache, and then return the value. So for that, we can write int value is equal to map.getKey. We'll do a put key comma value. This will update the position of the item in the cache, and finally once this is done, we just need to return this value. Now let's say if the item is not found in the cache, then we just need to return a -1. Let's try to implement the put function. So if the item is already present in the map, we'll have to update the position so as to make it the most recently used. So first we'll check if map.contains key. Then let's remove this key from the map, and again we'll reinsert it so as to update the position. Else, if the map has already reached its capacity, then we'll write a check for that. So if map.size is equal to capacity, then we'll just iterate over the map and remove the least recently used item. So how do we do that? Let's define an iterator of integers. So map.keyset.iterator. Now if you haven't used the iterator before, I have provided a link in the description. You can read more about it. So whenever we have to remove an item from the iterator, we need to call iterator.next, and only after that we can call iterator's remove method. So we write it.next and then we call it.remove. So this will remove the current element, which is also the least frequently used element. Once we are all done with this, the only thing remaining right now is to actually insert the element into the linked hash map. So we write map.put key comma value, and we are done. Let's try to run it. It works. Let's submit it. Great, so it's accepted. Hope you continue watching my videos. Please subscribe to the channel, like this video, and leave your feedback. Thank you.